Hello students, today we will understand the concept of radius of gyration. As we know that mass of a body resists any of the change in the state of an object of that body known as the property in terms of inertia. Similarly, moment of inertia of a mass particle or a body rotating about an axis is that property of that body which resists the change in its rotational motion. So it is considered as a measure of rotational inertia of the body. It means the moment of inertia, rotational inertia of that body. The different parts means the different mass particles, the constituent particles of the body are distributed at different distances from the axis of rotation. So the moment of inertia of individual particle is different due to their different distances from the rotationary axis. It means the moment of inertia is not a fixed quantity. It depends on orientation of axis of rotation and the position of axis of rotation with respect to the body or with respect to the mass particle which is rotating about it. So here we can define a new parameter known as radius of gyration. It is relevant to the moment of inertia of the body and total mass of the body. In all cases of rotating bodies with respect to an axis, we can write moment of inertia of that body equals to m k square, where k is the radius of gyration. Let us understand the radius of gyration with an example. For a rod about its perpendicular axis, passing through midpoint of rod, k square is equals to L square upon 12, where L is the length of the rod. So by the above relation we can write k equals to L upon root 12. The k is the geometric property of the body. Geometric property of body and axis of rotation. So the radius of gyration for a body is defined as the distance from the axis of mass point, the distance from the axis of mass point which has the mass equal to mass of whole body and whose moment of inertia is equal to the moment of inertia of the body about the axis. Now we will do an example problem for moment of inertia. A rigid massless rod of length L with a pair of small masses m by 2 at its two ends is rotating about an axis perpendicular to the length of rod and passing through the center of rod. So the moment of inertia of two masses will be equals to m by 2 multiply L by 2 whole square plus m by 2 multiply L by 2 whole square. That will give us 2 multiply m by 2 multiply L square upon 4 or equals to ml square upon 4. That's all for today. We will do some more numericals and example based upon moment of inertia. Till then, good day.